And the first time I saw an end mill move down into material, I was used to drilling, right? Done lots of drilling. First time it went down into the material and moved sideways, it like just like the movies. Life slowed down. There were sparkles in the air. I could hear the music, and I'm like, I got to know how this thing works. Like, this has to be part of my life.
Hello, everybody, and welcome to the Lights Out podcast. I'm David Vuyk, joined here with my co-hosts, Nick Goellner and Eric Nekich. And today we're diving into the one of the most transformative manufacturing technologies, really reshaping how parts are built. We're talking about hybrid manufacturing, and our guest today is Dr. Jason Jones, CEO and founder of Hybrid Manufacturing Technologies. He's a pioneer and a leading authority on hybrid machining and literally at the frontier of this technology. So Jason, welcome to the show and thanks for taking the time.
Great to be here. Thanks, Dave.
Welcome, Jason. Dr. Jason.
Welcome,
so
Jason.
Everyone I know who's a doctor is like, you don't have to say it, but I'm like, dude, if I went to college for that long, I would make everyone I would make my wife call me Dr. Nick.
Plus, I mean, Dr. Jones has got like just some cool kind of flow to it, you know?
And I
call me Dr. Jones.
I did my PhD in the UK, and so everybody said it with a British accent. So if you're a fan of the old Indiana Jones movies, it felt like I was living Harrison Ford.
I was just going to bring up Indiana Jones. I love that you went there. It's awesome.
That is the way to be, man. And Dave, okay, so like Dave does the intro now, and he's been doing the close. And the difference between him and me doing the intro is I just say something super dumb and then we start the episode. And he's got like preparation and structure.
Well,
and it's just so much better.
I feel like Dad just gave me the keys to the car. So, I mean, hopefully I don't like scratch it up or, you know, drive it off a cliff.
No, I'm going to make you drive me everywhere now. That's the only thing.
Well, guys, I don't know about you, but I'm really excited that we're, taking this topic up today. I mean, it's one of those things for me where I personally don't know a ton about hybrid manufacturing. We've seen the machines at trade shows. We kind of hear about the applications, but I mean, I haven't seen it in a ton of shops. And the numbers kind of tell us that this is a technology that's really kind of booming right now, really growing, and something that's going to be super relevant to a lot of people in manufacturing really soon. So I'm excited that we can unpack that here and learn from Jason. That's kind of what makes this episode one that, the listeners aren't going to want to miss. I mean, Jason, if you work in manufacturing or engineering or supply chain, how is hybrid manufacturing going to affect, folks in that industry in the near future?
Well, it really helps people at a very practical level do more with the equipment that they have, or a little bit more equipment. It's a higher utilization way of being flexible. And we love the amazing things like the assembly line that we look to as the absolute pinnacle of the highest efficiency process ever. And yet most of us have so much volatility in our demand and just changes in our lives that you need something that's more flexible now, right?
Well, it's just interesting because I remember I was at a specific machine tool builder, I won't name the name, and every one of the builders in their showroom had a hybrid version of their 5-axis mill. And the guy was like, yeah, I think this thing's awesome, but people don't buy them. And what you said, or maybe it was Dave, one of you just said like, it can work on any piece of equipment. So what's the difference here? Is it a special hybrid machine with a huge price tag, or can it really be adapted to any piece of equipment? Because that's something I'm a little bit unclear on.
So let's take just a minute and talk about that term, hybrid manufacturing, okay? Yeah, I started a business around hybrid manufacturing and named the business Hybrid Manufacturing Technologies. Our early patents didn't even use that term because it just wasn't super clear at the beginning. You're like, how do you describe a Swiss Army knife when it's the first kind of extended version of that Swiss Army knife, if you will? And so can it work on machines? Yes, it can. When we went to, so I was based in Europe for a decade, okay?
Where in Europe?
I was in the UK.
Okay, got it.
So, and I did a lot of European work. So I was on the continent often, and one of my great privileges was to work in the research world in metal 3D printing and polymers in Europe. in the time frame I did. And there was so much going on and so much funding, and I got a real great insights into what was going on all around Europe. And at that point, you could know virtually everybody that was serious about trying to progress this technology, both like commercially. You knew like every model of machine, every new material that got released, as well as the researchers and what they were doing, which was really fun. And then as we transition now, right, there's been a proliferation in lots of ways. And no single person can truly keep up with every little element of what's going on. It's impractical. But coming back to your question, we put this, when we first started to do this, we actually traveled Europe and we went and visited all the machine tool builders that we could get an appointment with. And we said, hey, we've made this really cool head. It fits on the end of a tool holder, so it fits in your tool magazine, and it allows you to print metal. And there was fascination with it. So we got quite a few meetings, and we drove all through Germany and all through Switzerland, a lot of big names in machine tool builders. And it was really exciting and fun to see them. And literally we were a company of 2.5 people, and got all these meetings. And most of them were like, this is awesome, and we don't know what to use it for. And we think it's great, but we're not going to do anything. And you're like, okay. So we got a whole bunch of feedback that said, eventually, but not now. So we said, well, let's start then with the ability to add this head onto existing machines. And it was really the user base that had the problems that helped shape this adoption pattern. And about half of the equipment we produce still goes onto a user's machine that's already in the field and isn't a new machine.
That's an interesting number.
What is up, Metalworking Nation, Making Chips family? It is an even year, which means IMTS is coming. September 14th through 19th at McCormick Place in beautiful Chicago. It is the largest manufacturing trade show in North America, bringing together thousands of manufacturers, OEMs, and solution providers every 2 years to explore how new technologies are being applied to real shop floors. So whether you're planning future capital investments, benchmarking operations, or simply trying to cut through the noise around emerging technologies, IMTS is designed to help manufacturers make better, more informed decisions. Whether you've been going for years or this might be your first time, put it on your calendar right now. Schedule your time away from the shop. It's good to get out and see new things. It's going to be a big party. I hope to see you there. Go to imts.com and register today.
Jason, let me ask, I know we're kind of off to a really great start here, but I'm really curious about you, how you got started. How did you land? How did you end up being CEO of Hybrid Manufacturing Technologies?
Yes, correct? You got it. So maybe the backstory is I had a gift as a kid at coming up with ideas. I wanted to be an inventor. And I literally have like my invention books back from when I'm like 6 and 7, right? Sketches and sketches and sketches. And we built my family built a home. And this was when I think I was 5. And all the offcuts from the railing ended up as these short pieces of wood with like a 45-degree angle on one end. And I thought they were boats. So I then proceeded to make every offcut I could get. I would make a different boat with a little sail, and I painted them all. And so I was immediately like hooked on making things and loved it. My grandfather was an architect and a contract manufacturer, right? Or contract home builder, I should say. And so I got lots of exposure to how to make wooden things and built chests and cabinets and all that kind of thing as a teenager. And I always wanted to know how to make things out of metal and plastic. And at that point, I just didn't have access. And so as I was searching through a variety of opportunities, as I started an engineering degree, I found a night class where I could go learn to machine. And the first time I saw an end mill move down into material, I was used to drilling, right? Done lots of drilling. First time it went down into the material and moved sideways, it's like just like the movies. Life slowed down. There were sparkles in the air. I could hear the music, and I'm like, I got to know how this thing works. Like, this has to be part of my life. So I did. I took the 3 evening courses to get you like the very boot camp of how to use a machine. And then within a fairly short time window, I did a more advanced class, and then I got a job as a part-time machinist. And that's how I put myself through my undergrad. I needed to work. I had to have income to just, make ends meet. And I'm so grateful. And the machinists there were so patient with me. I did everything wrong you can think of, from one of my favorite questions is, how did you break your first tool? And if I'm interviewing, it's a real machinist and they tell me they've never broken one, I don't believe them.
Yeah.
Or I rarely, I shouldn't say I don't believe them, but I just think there's so much to learn. I'm interested in how you got to where you're at.
So was your undergrad in the UK and then?
I did my undergrad in the US.
And where in the US?
I studied at Brigham Young University in a manufacturing engineering program.
Oh,
And
cool.
that's a less common engineering discipline, but I loved it. I felt like I had all these ideas. I could design a way for them to work, but unless we could actually figure out a way to make what I could think of, it would never practically get across the line. So I love that intersection
That's
of
fascinating.
it has to be makeable at a reasonable price to make it a viable business offering. And it's like the gateway to me that allowed you.
We've all seen like the high school movie where the girl comes down the stairs in her prom dress and the guy's heart stops, like, oh my gosh. But for you, Jason, it was just a tool moving sideways horizontally through material. And that was it, huh?
Well, I have had that experience on more than one occasion, and I will say one of them was when I got to know my wife.
Just a pretty giant leap there, Nick.
I just like, I think it would be like satirical, to make a scene like that. Like,
Just think, when all your buddies were going to prom, you were running a mill that night, weren't you? No.
I was not, but thank you for reinforcing the nerdiness of who I was growing up. Very, very comforting.
you are in the right place.
I think that's cool that you got your undergrad in that. And it's interesting, how many shops still, like within four walls, struggle with that leap from engineering and concept to the manufacturing floor. And it's a big struggle for a lot of companies. So we always talk about like the manufacturers you see doing really well tend to have figured out DFM.
Yeah. And another step, like running a company too, like running an effective business. Like there's a lot of people who are really good at like the tactics, making a part or whatever, designing. But then what I liked about what Jason said is, let's make this practical and let's make sure there's a real value proposition here and that it's saleable and we can run a business. And that's what you're doing now.
Getting all those things in balance and keeping them in balance while trying to have for me anyway, to provide for a family and have children and a wife. That balancing act, I think, is one of the great challenges of life.
Tell us about your family a little bit before we get back into the nerdy stuff that we're all here for.
I have 3 children. They're all fantastic. And they, so far, maybe 1.5 or 2 of them may follow in the sort of making things. Each IMTS, I have taken my child that's either a senior or junior, right? Because it's only an every 2-year show. And I take them to IMTS and have them help with the business. And so it's been their opportunity to be exposed to it. And of course, the first thing I try to do is walk them into one of the main halls. And often Fanuc has a large robot waving around a red Corvette in the air or some other cool car. And so we go there on the first day typically, and they're like, wow. So it's fun.
Kudos to Fanuc, because that's like the thing that everyone remembers is that car swinging around. So.
It's so great. And I hope they get to keep doing it. I know there's been, they're trying to move it around and keep it going. So
yeah. Cool.
Thanks to Mike Chico.
But I absolutely love that, and what a buzz, man, that your children like kind of just have that innate ability to want to create, to want to like. It's so interesting how many families that just kind of keeps working down through the different generations. So
well, and for at least one of them, her experience was the opposite. She's like, nope. But I want them to like engage with customers and be able to try and explain some portion of it. You go to IMTS and there's the people who are hired just to give you a bag, right? And they're dressed up and they look like they belong on the stand. And you ask them a question and they don't know anything. And so my hope is that they can engage in the process, right? Mm-hmm. And start to get a feel for, hey, what do you do? Well, this is what we do generally. And here's a bag. And I can get somebody to help you with a more detailed question.
Yeah. Well, that's what you have, I would imagine. There's products in our industry that kind of sell themselves and everybody needs them. And then there's products where it requires a lot of explanation and you really got to sell it. And you really got to explain it because it's pretty new. You would fall into the latter category. And you brought up that when you were in the early stages, I think where we were at in your story, you were saying about half of your applications are in real shops to solve real problems. Let's get into some of that. Like, what are some of these real practical problems that make hybrid manufacturing feasible?
to address that, let's talk about one or two things. 3D printing is such an exciting technology, right? And we talked about hearing the music play and having it be a special moment. The first time I saw a 3D printer and really appreciated what it was doing, the first time I saw the parts from a 3D printer, from a metal 3D printer, I looked at them and I said, this looks like a piece of garbage. Like, the surface finish was so poor. I was used to machining. I'm like, I don't know how this technology is ever going to make it, right? But then as I stepped back and appreciated more fully why, how it was being made and what it could do, I heard that same music again, right? Now, because every business needs to market their technology, 3D printing has had, I would say, its fair share of the limelight. And the promise there, I think it's worth it. And most 3D printers don't produce finished parts. They produce a form that can then be finished by other operations, often including machining, especially if it's a metal part, right? And that whole workflow does not routinely get discussed. It gets sort of, if you're in the 3D printing world, they're like, hey, we printed this. Oh, and there was some post-processing. And if you're in the machining world, you're like, well, we got this as a preform, but man, we had to do this machining and that, and right? All these operations downstream. And so to me, hybrid manufacturing is about pulling together all those steps under digital control. And occasionally I see people say, hey, I'm doing hybrid manufacturing, and they've got a 3D printer on one end of the shop, and on the whole other end of the shop, they're machining it. And I'm like, well, it is true. You're going through a workflow that in its broadest definition, you've got different types of processing going on. So it's a hybrid workflow. But usually the reason we used hybrid manufacturing is because when you can pull it together into a machine or a tandem suite of things that are fully automated and fully coupled together, you achieve efficiency that's unparalleled, right?
Yeah, I think a lot of folks kind of understand 3D printing or CNC machining, and they kind of have them in two different categories. But really that magic of bringing them together just brings this element of productivity and automation, just by virtue of the fact that you don't have all this wasted motion going from one machine to the next, especially if those machines are on either ends of the shop floor.
Yeah, I'm glad you said that, Dave, because I was just thinking about maybe part of the problem is like the overhype when additive was kind of like booming in everybody's minds, and like, oh my gosh, we won't need CNC machines anymore. And then all the CNC people were like, Jason, like, look at that part, looks like a piece of crap, and it created this like weird either or dynamic that I was kind of like, it's almost like, Jason, your job is to be like this marital counselor. That's like, you both have a lot of value. You just got to have to work together.
That's a great analogy. And actually, if you go back to the mid 2010s, we actually won an award. We were fortunate to be featured in, I spoke at many major events. And I would often say, CNC machining is not going away. And there was an audible gasp of relief that I could routinely heard for several years. In fact, I had one very large machine tool brand everybody knows. And he said to me, I don't want to deal with this because I already know it's not going to affect my profits for the next 5 years, but my board has given me no option. And I'm like, well, I'm flattered. Great to be speaking with you.
I'm being forced to talk to you.
My parents made me come.
Exactly right.
You know what's interesting is it like when we talk about hybrid, right, and seeing some of the commercially available machines right now, right, and I go back to maybe not this last South Tech, but the one before, where Philips hybrid actually had like a Haas VF2 with that spindle attachment, that tool you're talking about, and it just reminds me of like when you would see people around the first 5-axis machines, right? There was this crowd and there was this buzz, and it's like everybody knew that they were looking at the future of manufacturing, but then you kind of walk away and it's, how do you get to the application phase of that? Because they were 3D, it was printing these little open-ended wrenches, right, and it would print them and in the vise, and then it would go right, and then the whole table would move over and go right into the milling op and done. And so just a fascinating process, right? But yeah, a lot of buzz, and just curious, what are your thoughts on application? Is it something you see the next year, 3 years, 5 years?
So there are already applications happening now. I think we need to set this up with one other piece of framework, if you'll indulge me. Okay.
Yeah.
And I will come back and answer.
Absolutely.
In fact, let's answer the question now. People who do repair, like a hybrid all-in-one machine that's got the ability to add and subtract, and especially if it can inspect as well, you get this whole suite where that is a killer application for a hybrid all-in-one machine. And it's an awesome place to start because of this dynamic. 3D printing, part of the reason it's exciting is because you can make really interesting geometry. And that's what's easy to see and to measure, right? Especially if you're in a machine shop, you're used to being able to measure form and accuracy and precision. What's harder to measure is what it's made of, right? The chemistry and what influence you've had on that internal microstructure. When you 3D print, you automatically influence those. And it's a little like Spider-Man, right? I can use this power. I promise to use this power only for good, right? With bringing this power comes tremendous responsibility, and you're trying to use it well. And yet we haven't done a very good job as an industry. And when I say industry, we could talk about additive, we could talk about metrology, we could talk about, this broader hybrid manufacturing movement. We haven't provided the tools at a very practical level to most machine shops to know if their parts are any good. And, since we've been on the discussion about family and marriage, I have 2 daughters, one very recently married, but at last IMTS, somebody presented me with an investor. And this investor had not had the success they hoped for with 3D printing. And they said, what's the issue? Why did we struggle? And I said, look, let's make this really short. I have 2 daughters that are, one's marriageable age, the other's rapidly approaching. When they talk about a guy, and I start to hear about a guy that they're interested in romantically, what do I hear about first?
All the great things.
Yeah, the hair, the eyes, the smile, their night, all that stuff.
All the surface level stuff. Yeah.
And it's all good stuff. And I would like them to be attracted to whoever they're going to spend their days with. But I said it as a father, what do I care about the most?
Yeah, the underlying structure, is he going to be able to provide? Is he going to be faithful?
That's it. I care about the guy's heart, his integrity, who he really is. Does he really care, and is he going to be committed and take care of this person?
Yeah.
And I said, I think what you're, using that as a little bit of a counterpoint, often with additive or 3D printing, the external geometry is so exciting and certainly delivers value. It does. Mm-hmm. But if you miss the internal characteristics of that material, then you've really compromised a lot of the value it delivers.
So you are a family counselor. I had it right from the beginning. No, but back to the nuts and bolts here. So you talked about how it could change the microstructures. Mm-hmm. And so the first thought I had is kind of like work hardening, like how while you're machining certain pieces, it actually changes the material properties and stuff. I imagine to keep the metaphor going, when 2 people come together and they start living together, doing life together in marriage, they kind of change each other. And it's is this really compatible? And is that one of the biggest challenges is as those microstructures change, the compatibility might not be what conceptually the promise was supposed to be in the application?
I think that's a fair analogy, right? Many of the 3D printing processes that we use are based on heat. And heat and pressure are the 2 things that really determine the strength of how material, how it ends up based on the chemistry that's inside of it. And you got to get that mix right. And what we're used to in the CNC world is all of that happens upstream, with the exception of maybe work hardening and, your cutter does affect the outside skin of something as it rotates, right? Based on its heat. But most of that internal structure is already set when it comes in as a billet or a rod or if it's casting or forging, either one. You've already determined that internal microstructure. And your responsibility then is exclusively about the outside shape. And that's why we're so good at, using a CMM and touch probes and, scanning and all those sorts of things to establish, hey, is it accurate? And yes, I know how, and I know how to do this and I can validate it. And therefore the parts I sent you are good. But when you say, hey, what's the microstructure? What's the strength? What's the chemistry on the inside? Most machine shops are I need some help with that. I mean, I can send it out to some lab or university, but it's not as standard of a practice as they're used to.
Yeah.
And so part of creating this hybrid manufacturing workspace is not just adding metal or finishing it, but also being able to interrogate it. So if you look at some of our really successful applications, you're like, well, there's ultrasound built into this machine. You're like, well, what's the ultrasound for? Well, it's to look on the inside of the part. Or how about an eddy current inspection? Or how about, right? There's these other aspects where you're like, oh, you mean you can actually now know what's on the inside? Yes. And then when you lean up close to a hybrid machine operator or an additive person, you're like, hey, how do you know this part's good? And they're like, it's the same as the last one? I'm like, wait. Was that an answer or is that a question?
That's honestly a great segue into what my next question would be, and that is, what do you think's holding most manufacturers back from adopting this technology as part of like their production workflow? I know we talked about two separate sides on the shop, but I'll be quite frank. I don't see, you see the mills everywhere. I've seen a few real world applications where they're 3D printing parts. In fact, I've seen one up close and personal where they were repurposing like blades, bisque blades, right? And the top is what wears out of the blade. The core of the blade doesn't. So that gets milled down. They 3D print essentially a new tip. A probe comes and measures it, assigns an adaptive tool path to a cutting tool that then comes out and like mills it all smooth. So it is fascinating. And I mean, you could just look at that and see the dollar signs as to what a valuable process that has become. But what do you think's holding a lot of manufacturers back from like jumping into this?
I think it's having quality there's confidence that the quality they are outputting is good.
It kind of, from what you're describing, it sounds like this is a really different workflow, like design to finish part. There's elements there that, frankly, shops just aren't used to. I mean, is there an education part to that? I mean, could you walk us through like design to finish part? What are the steps, and maybe call out some of the things that are unique to hybrid manufacturing?
Sure. What's unique is that normally you buy your billet and your feedstock in with a cert and you know what it is. The biggest change is that now after I've printed it, I have to reestablish what the quality of that part is. And it varies with how safety critical the part is, right? If this is something that's used for a cup holder, well, what's the consequence of the cup holder failing? And I use cup holders on purpose, like fold down trays and airplane seating. The weight of that is a big deal, right? And so there's actually a lot of 3D printing that goes into those, because if you can take out however many pounds or kilograms and lighten it, you use less jet fuel over the lifetime of that aircraft. So it actually, taking out a little bit of weight can result in millions of dollars of savings on the lifetime operating cost of an aircraft, which is really cool. But it's not the way we tend to think about things on a part by part basis. Usually it's like, hey, what does this part cost? And can I get this part made for a little bit less? So now we're trying to invert it, but that's a lot of the core around it. First off, if you're in a machine shop, the first question is, do you have design authority? So many of us get handed a set of drawings and it's already stamped by the original OEM, and they're like, this is what I got to have. You don't have any choice to reshape that part. You're locked in, right? And so in that sense, hybrid manufacturing is really outstanding if you're able to vary the composition of it, or if you're doing repairs. So I love that example, Eric, of blade repair. And in fact, some of our first applications were on aerospace blade repair and also impeller repair that went inside Cummins, diesel engines, that turbocharger. Similar thing. You got a part that's made out of a high value metal, mostly nickel. Usually they operate at high temperatures, right? And as it rotates, theirs rotate at 40 to 60,000 RPM. You wear out those edges at just literally that outer skin, if you will, like just a couple of millimeters. And if you can print it back on and finish it in situ and blend it all together, it's really much easier than going and recasting new parts and finishing those.
All right, shop owners, listen up here. I think all of us know we are in one of the most capital intensive businesses there is, and margins are tight, and we're always fighting issues. And then when we make money, What do we do with it? Stock market's up and down all over the place. Well, I get asked a lot about where can I invest my money? I'm a firm believer as business owners, you've got to invest in yourself first. You need to reinvest capital into yourself. So the number one thing that I've done in this industry in investing was ProShop ERP. We've been using ProShop since 2018, and my payback literally was within weeks. With their per user based pricing, I knew when I made the decision, I only needed to save my workers roughly 1 hour per month. We saw within the first week, we were saving multiple hours per day. That type of ROI just doesn't come along very often. Outside of that, the real value is being able to quickly implement best practices across my entire shop from the time we get an order to the time we ship it, scaling my business with confidence, being able to go out and know that I can deliver on my promise to deliver quality parts to my customer, and then gaining insights into every job, employee, machine, and every process in our business to really drive efficiency and look for opportunities for improvement. That's where the real value in your business drives. So visit ProShopERP.com, book a demo, and start realizing ROI today. That's ProShopERP.com.
Yeah, you mentioned aerospace, and I'm thinking defense, aerospace, medical. These are all like highly regulated industries, and you mentioned material certs. And so I imagine that's part of the hurdle too. You like the design freedom that you get or don't get when the material has to be certified, everything has to be certified, and there's really no, I guess, freedom, or there's no accommodations being made for how that could change when you add the additive process. Do the regulations pose quite a barrier for adoption?
So I would argue that for repair scenarios, they've pre-existed this as an innovation.
Okay.
So they're actually an opportunity to get this sort of technology into highly regulated industries, because really it's an automation solution. Instead of moving it between 3 or 4 different pieces of capital equipment, and just as kind of terminology, if you think of a pinball machine, you know how like you hit that ball and it goes and bounces around. The more complex your workflow, the more pieces of capital equipment a part has to touch. When you start to think about shifting to a hybrid machine that's got these different capabilities all built in, you reduce that kind of pinball bouncing around effect, and you just get lots of efficiencies, especially if you have to outsource some of those steps, or you have to or it's at a whole different manufacturing facility and you're shipping it around. A lot of our customers bring on hybrid manufacturing because it eliminates that need. They no longer need a coating that's put on externally. They no longer need to get some certified measurement done externally. They know in that moment that it's good.
Yeah, they no longer need to find their place in line at the next machine. That's the other thing. You might, if it has to bounce from 5 machines, they probably make other parts too, and now it's just got to sit there and wait in queue.
Yeah, what's the rule of a piece of capital equipment? Make sure it's highly utilized, right?
Yeah.
And that ends up, then you have a pile of work in process in front of it, and you reduce the way you can actually respond. Okay, but let's catch the other part of that, which is the more highly regulated industry, as you shift, I'm going to say outside of repair, which isn't already kind of a known thing. Then yes, it's easier to go and look at, hey, do you make mold tools? Great, as long as you can certify that it's accurate. Usually it's the parts that are regulated, not the mold tools themselves, right? So then as a tool maker, I have the ability to implement this because I want to shift this gate over and make it a little bigger. And there's already a fair amount of manual welding that goes on, and there's kind of a limit to how much you can manually do. And now automated, you can often expand on that, make it a little better, a little bigger, a lot of fixturing, a lot of measurement. Maybe you could shift from actually making metal, fixtures for parts to something that's polymer composite. A lot of our polymer composites are the same stiffness as aluminum. They're way easier to machine. They don't rust. They're much lighter. You can recycle them, right? There's a whole paradigm around, I'm going to shift fixturing over into polymer composite. And yes, you can print that on a standalone 3D printer. Or if you need to make stuff at larger scale, we can put a head in your spindle and you can output, large scale parts in relative terms. If you're accustomed to desktop 3D printing, right? You can get parts that are a meter or meters long very, very quickly using your CNC.
Oh yeah, I was at Danville and saw like a big gantry-style version of this and was just taken aback. I mean, and to your point, printing like big parts, I believe, for the Navy. So yeah, it's insane. I mean, that caught me off guard too. Like, you think 3D printing, I probably think of my little Creality printer here, and you're thinking like parts the palm of your hand, and then you see something. I mean,
Yeah.
it was, boy, it had to be 3 feet, 3 feet, 3 feet. It was just huge.
Yes, and for us, it's like, hey, what size machine tool do you have? Well, if it's a 40 taper machine, chances are it's probably about 40 inches long. Well, you can make a 40-inch long part, right? No problem. And if it used to be made in pieces and then all assembled together, now you can make it as a single piece. Often you're getting efficiencies there.
I'd be curious, Jason. I mean, what has the response been from the engineering office? You talked a little bit about design authority. I mean, are designers willing to design parts with this as a manufacturing process in mind? Are they aware of it? Is it easy enough for them to find manufacturing vendors that then can produce the parts if they do design it with hybrid in mind? What does that look like right now?
So you're in the chicken and egg scenario, right? Of I need a designer to make a bet that this technology is going to make it. I've lived that risk and we've lived through it. That the risk is no longer a risk, right? If you're a designer and you're wondering if this is going to make it, it has made it. It will continue to be a strong and growing feature. So I'm really pleased to say we've reduced that risk for you. But getting a team on board to take the risks to do that or to invest the cost, they've got to see a payback. And I would say a lot of times it's about somebody, they often want to dip their toe in the water, and repair is a natural way to do that. So then how do you get from that to building a full part? And for us, usually feature addition is a really interesting way of doing it. Especially if you can say, hey, I've got some tubular part and I need, right, some spigots or some flanges or some other features on this. Can I get maybe a generic forging or casting and then do late configuration on this? So yes, I'm committing to some tooling to get a forged part or a cast part done, whatever that is. But once I've got a stream of that, now I can late configure that into 6, 7, 8, 10 different things. And I get the speed of the digital additions without having to build the whole volume using 3D printing. So earlier, one of you said, hey, it felt like this either or. I'm going to either 3D print or I'm in a machine. And for us, that decision should really shift to a feature by feature decision. Does this feature make the most sense to cut out of a solid billet? When it does, do that. And then when it transitions to be like, hey, it makes more sense to 3D print it, fantastic, do that. And now you've got these parts where you're going to assign this feature will be printed up as a rough form and then machined back to its final shape. That to me is where you really start to leverage the strength of this process. And if you'll indulge me, I'll tell you a quick story. So the first time to certify blade repair for aerospace, well, we originally started for ground. We did it with GE in one of their European facilities. And it actually began as an Alstom project, and GE bought Alstom. So I want to give credit to both organizations because they are both part of it. And once they got to the point where they had certified this repair, they were literally re-tipping the blades. And at the root, there's a fir tree structure on some of the blade models. They were actually correcting it, repairing it. And then they got a whole set of blades in from a customer one day, and it was an older revision. And so they looked at the documentation. They said, you know what? We could actually make this turbo equipment operate more efficiently if instead of just repairing it, we actually added enough features to up-rev it to the later revision. And that's what they did. They had got enough confidence now that it wasn't just a repair. They went ahead and added those features in, returned those blades to the customer, not just to like get them running again back at the efficiency they were. They actually boosted the output because they had up-revved it, which I love. And that's just the natural progression to me of having confidence in it and then spreading that technology further.
Yeah, having that many tools in your toolbox with hybrid.
That's right.
So looking at that and the adoption rate as it goes up, I mean, Jason, do you see, I mean, from your perspective, would you consider hybrid just sort of a stepping stone into Industry 4.0, or has it already become a central pillar, in your opinion?
So I need to be careful because if you look up Industry 4.0, they're not going to say, hey, hybrid manufacturing is a pillar. But the embracing of how do we actually get digitally driven decisions to move between different modes of manufacturing. Hybrid is absolutely one approach to embody Industry 4.0. It's not peripheral. It's not a good idea. And people ask me the same thing about, hey, how much AI are you using, et cetera, et cetera. And my answer to that is, hey, we've been using machine learning for a long time, and that is a form of AI. But in terms of actually handing over control of a manufacturing environment to AI, most people still want a human in the loop at some point, right? To guard against artificial ignorance, which we don't talk about enough, but that's a whole different type of AI that we need to continue to combat. But right now, conventional wisdom says, for me to have this wonderful factory that's all controlled digitally, I now need to put a robot in between every piece of capital equipment I have. And there's some utility to that, and there are cases where that's absolutely the right thing to do. But for many institutions, especially in the medium and smaller machine shop range, they're not at a scale where they're just going to flip a switch and then go put a robot in everywhere, right? Yeah. A hybrid machine enables you to at least use two different purposes, and often three or four, without a bunch of extra overhead for automation. You're essentially leveraging the tool changer, right? That tool change arm to switch between things. That's a really powerful way to start to embody these. And one of our applications now actually has a part that's being repaired that requires ultrasound inspection at multiple stages, right? They get the parts in, they have to do a skim pass, then they have to ultrasound those to see it's a multi-metal part. It's a bearing surface. So you got soft metal on top of a harder metal. And they actually have to look in and check the interface between those two and say, is it still good, right? Is there delamination or is it still fully adhered? So that's the first time you do that ultrasound step. Then they go off and they add more metal and do some machining. Then they've got to bring it back and check it again. And because the final machining step is quite long and there's a high precision that's required, they usually do it before they do the machining to double check that as they've added that extra metal, they haven't messed it up. So you're usually doing that ultrasound step 3 times, right? This pinball of it's bouncing, or even ping pong in this case, right? It's going back and forth between inspection and a machine. Bringing in a hybrid machine, I mean, it literally cuts the number of moves from like 7 or 8 down to it being in the same machine the whole time. Gosh, and the operator gets the feedback immediately, and you can just run right through, right? So you have usually an op stop. You're like, hey, here's the results. Op stop. Operator's happy. Go to the next thing. Go to the next thing. Part's done, right? In 40 minutes instead of moving its way around for days and days, waiting between these different stations to be ready.
Wow. Yeah. For an automation podcast, we do a lot of discouraging people from adding robots for the wrong reasons or like without lean thinking.
Sure.
And one of the things that we say often is when you automate something, you just like add to the bottleneck before and after whatever you automated. And if you're not thinking about the entire process, you can really get yourselves into maybe even more trouble than if you just didn't buy the robot or whatever the automation was. I think the antidote to that, though, is a lot quality. You talked a lot about quality. That's often where we bottleneck things, and having dynamic machines that can multitask. And you just gave a perfect example of that. Now you've described, okay, well, just with the tool changer and changing the head, you can add additive capabilities to your machine. But how difficult is it to add the quality and the in-process inspection elements to it? Because I've never seen that, and I don't know how approachable or affordable that element is.
In a lot of ways, it's easier. And let me tell you why. Some of the most popular types of 3D printing for metal require either an arc or a laser energy source, and they generate a lot of heat, right? And so you've got to worry about, hey, can I expose people to radiation in some way, whether it's laser energy or arc? And something's going to be really hot. When we talk about inspection techniques, often it still includes a laser, but it's a much lower power laser. And when we go to eddy current and ultrasound, all of those, for us, eddy, ultrasound involves coolant, which everybody's already using. And so there's not the safety concerns that you need to guard against. And so adding it's typically easier. Now, let me pause for a minute. CNC controllers have grown so sophisticated in all the right ways, which is awesome. They're also relatively locked down, right? You want to add something to a CNC control, and even the machine tool builder, and this is not a hypothetical example, will be like, hey, I need to change to your PLC. And they're like, yes, that will be done on the other side of the world remotely between the hours of, if you're lucky, and if you speak the right language, and. Do you know what I mean?
100%. Yeah, I wish Caleb was here. He'd probably start weeping.
So we've tried to be very practical to commit the right level of you can drive a toolpath without any issue. You can also typically trigger a set of simple signals, and usually it's a go, no go decision, right? If you've got a good, body of, hey, I know what's good and I know what's bad. You're like, okay, let's set the threshold here and you can get a go, no go. It's a no brainer, go forward with it. If it requires more sophistication than that, then you're likely going to involve a human still. And yet, as opposed to having to take it off of a machine and go run it down to the other end of the shop and wait for them to say yes or no or whatever else they're going to do, getting that feedback immediately, even if initially it involves two people, to say, hey, you're going to have this person look over your shoulder and train you on how to use this until you're comfortable. I think that's a wonderful way to make things more efficient and to grow your people, right? Well, one of the things that I love about hybrid machines is the people using them are typically really excited about work because they're learning something new and they're exposed to all this cool stuff, and it's invigorating to see the possibilities, right?
That's awesome.
Absolutely.
It's awesome that you brought that up, Jason, because what I was going to ask is, a lot of our audience are the kind of folks that want to be on the leading edge, at least from a knowledge perspective, but in a lot of cases also having this type of equipment on their shop floor, making the investments in automated solutions and so forth. So in terms of where the technology is right now, I mean, is this the time for early adopters to make those investments? Should it be part of their 3-year or 5-year plan? How should leading edge shops be thinking about hybrid manufacturing right now?
And before you answer that, let me just piggyback on that. Integration challenges, any common integration challenges that maybe they should be aware of. If that's not if that didn't just make it too convoluted, sorry.
No problem. So what I would advise is, depends on the scale of your facility and your budgets. I will tell you as an NDA trend, right? Non-disclosure agreements. In the beginning, we had a few people who were willing to talk about what they were doing, but most wanted it behind closed doors. The trend growing over time, especially the last 4 or 5 years, is people want others to know that they've adopted this new technology, right? That swing we've seen come through full circle. So if you're watching for peers to take this same leap, you're now in a good place. And I tend to find that there's those who are happy to be pioneers and they go out and they're truly early adopters, right? And they're like, I don't care what everybody else is doing. I can see the value and I'm going to pursue it. And then there's that group of people who says, hey, I can see that it's good, but I don't want to be your guinea pig. I don't want to pay for all the first mistakes. I want to be that next wave that adopts when it's, right, a measurable return, but I'm not learning everything for the first time. We're well and truly into that zone. And there are lots of people who have already adopted, who are adopting, more and more people that are willing to talk about it. And so if that's where you characterize yourself, great. If you're one of the last people to adopt because you're still trying to use a typewriter or your IBM wheelwriter or whatever, it's not there yet, right?
Sure.
Every problem has not been solved.
You have to have a tolerance for that as an individual, right? Like, hey, they don't have all the answers yet. You have to have a tolerance for some figuring it out.
That's right.
Yeah.
But it's not uncommon on a repair, an automating of a repair. If you have throughput of parts you're repairing regularly, it's not uncommon for us to achieve something like a 6 to 7 month payback on capital equipment when you implement it into your repair. And so usually the technical people are the most interested in it, and then the finance people are interested next. And what we're finding is more and more people, once they get into it, they're like, actually, fiscally, we would be irresponsible not to seriously consider adopting this over the next near term because it can boost productivity if you know what you want and if it's a good application, right?
Well, you gave us a good application earlier, and so I'm going to give you the question that everyone answers with "it depends," but I'll try to reduce the "it depends." So, so let's say you're a shop and you're making a family of parts, and you may have to add features, like you said, a spigot or a boss or something here, and here. And so that's the work you do. And you've got a variety of ways to do it, but you don't always want to have to go get a new casting, a new pattern, new whatever. So you're listening to this, and what Jason said is like, that's our business. We might be a good fit. What's it going to cost me? That's the question. So what's it going to cost if that's kind of my wheelhouse? The parts are something that, could fit on your desk or in a realistic kind of average size mill. What are you thinking?
If you want to implement one step, like, hey, I'm going to automate inspection for this, or I'm going to inspect, add polymer composite, right? Mm-hmm. You're probably in the, $40,000 to $100,000 sort of range ish. Okay. If you're like, no, I need metal 3D printing, you're probably going to be $250,000-ish to really go after metal 3D printing well. My personal goal is to keep bringing that number down, and we continue to drive it down. And so I'm excited about that, but it's now low enough that in those right applications, there's a pretty robust return. And it's not as if you're suddenly going to see a drop that's like, the next year you're like, whoa, it just changed another 40%.
Yeah.
Right. We're seeing it come down by relatively small percentage each year. And you'll have to talk to, whoever you would buy equipment from. Our approach has been all this equipment should be very modular so that if there's updates and changes, you can, mix and match those pieces out and you still have a very current solution and you're not stuck with something that's kind of a monolithic thing that's now very, very old.
So you said you've brought the cost down, and like any new technology, it usually starts like, only the elite can afford it. I remember hearing like the first laptop computer. It's like way more expensive than they are right now, even back then.
Sure.
How much have you brought it down since like you first kind of introduced a lot of this to where it is now?
So I would argue that, and let me give you a little bit of a comparison for what typically we're replacing. Usually we're talking about a machine tool, right? CNC machine, which remains, right? You continue to use that machine tool and the precision of the parts that come out of it are determined by its stiffness and accuracy and all that kind of thing, right? And so I've got customers on a whole range of machines from, very general purpose, lower end or medium machines, all the way up to the highest precision 5-axis machines you can buy on the market, right? The kind that do 80% of the world's precision ball screws for aircraft, that kind of thing. But you usually take that, you would normally pair it with a metal 3D printing machine, which on its own is often a few $100,000. And then usually there's a couple of different inspection stations. If you're doing ultrasound, often you'd have one of those that may be a similar number, depends on if you need full immersion or not. Then you often have something that's looking at cracks, which is a whole nother inspection technique. Plus, often people would have like a roamer arm or some sort of 3D scanning thing to go with it, which is another usually 50, 60, 80 grand. So if you take all those and lay them out, you're like, okay, this is like $1.7 million to, you know what I mean? Depending on your machine tool and all that stuff. And we're compressing it down to a 25% of what that is. Compared to where we were and where we are now, we've probably brought it down another, 40% on top of that. And as we continue to like carve out these little improvements here and there, it gets to the point where it's like, well, for this hybrid machine, it's just going to be eddy current inspection and machining. You're like, great, that's now easy. And it's an incremental attachment onto a machine tool, like you'd buy a 90-degree spindle. You know what I mean? Or a touch probe, a sophisticated touch probe, or a rotary axis. And people are always like, hey, when you make a hybrid machine, your spindle's idle while you're doing this other stuff. And you're like, yes. And how much of that machine tool are you utilizing? Do you have a 4th axis sitting there on the table and 3 vices, and you're only using 2 vices at once and the rotary's idle? So I need to acknowledge it's a legitimate question, right? Especially if it's a higher cost thing that you're utilizing or not utilizing in the moment. At the same time, the whole manufacturing world's constantly balancing this demand versus flexibility, reducing setup time, all that kind of thing. And we just simply need to make a recipe that says, do you know what parts you specifically want to do now? And if you do, it's very easy to build out, okay, here are some assumptions, and yes, it works, or no, it's not right. And we try to be pretty practical. It's not right for everything, not right now. And yet things that even 2 or 3 years ago weren't practical and weren't a great value now are. So it's an exciting time.
Hey, it's Paul from Making Chips. If you've been burned by recruiters who don't understand manufacturing, you are not alone. That's exactly why we created Hire MFG Leaders. We're not just recruiters, we're current and former shop owners, and we know what it takes to lead in this industry. Whether you're hiring your next operations leader, sales manager, or production supervisor, we'll help you find someone who actually fits. Learn more at makingchips.com/hire.
It seems to me also that outside of the cost of buying the technology, there's also the implementation and developing the skill set, which to me seems like you'd want to be really careful in finding the right partner to help guide you through that process. Could you speak real briefly to kind of that process too?
Part of the insurance, if insurance is a word we can use for our customers as well as us, is we'd like to participate in some of that pilot production work. And so if we can do some of the parts, let's test some of the hard parts. Let's test a couple easy parts. Let us make you these parts. The first time we make your parts, it's always more expensive than it costs you to make them because we've never made them before, right? So we're like, hey, this is an exploration project. It's going to cost more than the actual per piece cost because we got to get it all set up. But let's set it up and do it. And then we can estimate what a per piece cost is. And now we've got real data that says this was the one-off cost. Here's what we think it'd be on an ongoing basis, and then compare with what you're doing. And if we have that open dialogue, it becomes a very, rich experience that says, well, this works now, or it may work later, or it may never work. But at least you got something that's ending.
Yeah, so you're not just delivering a precision part, you're delivering a proven process that you were there as a partner to help them prove that process.
That's right.
That's really cool.
And the same is true with the inspection. Usually you're taking, as I said before, an operator and you're giving them quite a bit of power. Mm-hmm. And frequently they may need somebody over their shoulder or maybe two people over their shoulder that says, okay, well, for this aspect of it, I need you to weigh in on it. Like, is this good data coming back? And is this adequate? Are you comfortable with this? And you end up like kind of a welder and a machinist and an inspection person all kind of huddled around. I love those moments because you've got this, you're taking what has been siloed knowledge within any company and you're cross-fertilizing it and allowing everybody to speak a more unified language.
That's so cool. So you talked about the partnership aspect, and just, as we close here, I want everyone to appreciate the legend that is Dr. Jones. You've been involved in, what'd you say, 11 builders developing their hybrid machines that you could see at IMTS. Like you're kind of the pioneer in this, aren't you? In a way, I know you're a humble guy, but
so this idea existed academically, right, for quite some time, and there's various people who have contributed to it. But to our awareness, we're the first people that ever made this commercial. Yeah, and we've helped the majority of people who have a commercial offering do something, either if not directly through us, then through somebody we touched who then passed it on. So we're thrilled to have helped seed the market and spread it wide enough that it's a real market, right? This isn't just one or two people saying, hey, this is a great idea. Now you've got robustness and alternatives, and a lot of that's to give these designers confidence to say, this is here to stay, especially for a catchment of applications and design around it, because we've talked a lot about repair today. There's so much beyond that that's made practical by the, adoption at scale, if you will, of all these principles.
So cool. Are those partnerships available online on your website or something like that for people to see? I would ask you to list them, but there's so many, I don't want to accidentally leave somebody out.
We've asked permission and have permission to show a bunch of logos. All the logos are real people we've done real things with on our website, which is great.
Cool. And how can people find you?
I was going to say, what is that website if people are looking for it?
So it's hybrid-am.com.
Easy.
That's amazing. Cool. Everyone should be able to find that. Jason, every time we close up an episode, we want to leave the listeners with a bit of a plan of action. Obviously, that's not necessarily going to be go out and buy a hybrid solution, but do you have any kind of anything you want to leave the audience with that they could do just to kind of grow their understanding of hybrid and where that should fall within their automation strategy if they're contemplating one?
Well, let me offer this. 3D printing offers, if you get into the details, quite a few different value propositions, okay? Of necessity, for those who use machine tools, we've looked really carefully to study those. Some of those are to create a really unique shape, and they tend to be very exciting looking, and you can see lots of examples of those online. Another opportunity for 3D printing is to actually make multi-material parts or to change the material they're currently made in. Those often are rather mundane looking parts that you would look at and shrug your shoulders and be like, it's just a flange on a tube. Like, yes, and right? When you can do that at a fraction of the cost that you've ever done, it becomes exciting. So I would say balance, if you will, what is the shininess of new things with the practicality of things that may even look dull or boring, and be specific with what you want out of what you're trying to automate. As you all have rightly articulated, the initial idea of automation is I'm going to bring in all these robots and all this digital capability. And the reality of automating is a lot of the hard work has to do with you looking seriously at how you're doing things and making preparatory steps for that will pay dividends regardless of if you ever transition to the next step or not, but really evolving and improving yourselves. And I would say the research people go through to say, hey, can we do this another way, often allows them to see an improvement in the way they're already doing it now with their existing equipment, which they may implement as an interim until that savings accumulates enough to allow them to invest in something more.
Wow. Really well put.
I was going to say that's a good one to chew on. I think that's an awesome way to close out the episode.
Absolutely.
Jason, thank you so much, man. Holy cow, I was excited. I think we met a couple years ago, and I was like, gosh, I want to get this guy on the pod. So happy that we were able to make it happen.
Lovely. Thank you.
Another shout out to Boombastic. We crossed paths with Jason there and just had a great conversation. And we were like, why aren't we recording this right now?
Those are always the best episodes.
Really appreciate
the episodes where you were like, man, we should have recorded the first time we talked. So
it's been great. Eric, Nick, Dave, thank you so much.
Yeah.
Awesome.
Yeah, and can't wait to have you back on for the sequel, Dr. Jones 2, Electric Boogaloo. I think that makes sense later this year for sure.
I can see the preview now in my head.
Keep learning, everybody. Appreciate it.
Take us home, Dave. You're so good at closing these now. So
I'll give it my best shot. I think that's a wrap for today's episode of the Lights Out podcast. A huge thanks to Dr. Jason Jones of Hybrid Manufacturing Technologies for breaking down what hybrid manufacturing is and how combining additive, subtractive, and inspection technology into your workflow is really changing what is possible on the shop floor. If this conversation helped you to think differently about process flexibility and where hybrid manufacturing fits into your automation strategy, make sure that you like and subscribe so that you don't miss any future episodes. And share this episode with a friend or colleague who's looking to stay ahead as manufacturing technology continues to evolve. As always, Lights Out Manufacturing isn't about choosing one specific technology. It's about integrating the right technology to build a smarter, more resilient operation. We'll see you on the next episode.